Okay, as people are coming in, I'll just get started. Welcome to the Vernier workshop. Our chemistry focus today is teaching the electromagnetic spectrum virtually, part one. And I'm joined by Melissa and Noose, who will be your hosts for today. Just to let you know that we do have handouts and other items available to you that will be shown throughout the workshop today in a shared Google file. So I'll be putting that in the chat feature of Zoom here. So you'll be able to click on that link and access the handouts. We ask that you use the Q&A feature for questions. Noose is going to be helping to field all of your chemistry questions, and Melissa will be taking questions during the workshop as well. And if we happen to not get to your question during the presentation, don't worry, we will definitely follow up with you afterwards, and you'll get your questions answered. And also to let you know that the recording is going to be available of this workshop on our website if you go to our online training library. And I'll also put that link into the chat feature as well. So you have that as an easy link to get to. And it'll be available in the next few days. And then also to let you know that we can provide and will provide a certificate of attendance for all of you who are joining us live today. So I will pass this on to Melissa and Noose.
Hello, everyone. I'm going to go ahead and share my screen with you. All right. I hope that's coming through. All right, well, people are filtering in. I'll just kind of get started with a little bit of background and housekeeping items. But first off, welcome to teaching the electromagnetic spectrum virtually. And as Angie said, this is part one of a two-part series. This first part is mostly about absorbance and transmission of light. And next week's one, I believe it's on Tuesday, is part two, and it's mostly about emission of light. So you could say this one's more the molecular side, and next week's more the elemental side, however you want to think about it. But definitely sign up for part two so you can get the whole part series. And let's go here. So I'm going to go ahead and let Noose introduce himself.
Hi, folks. My name is Noose Hissam. Right now, I'm a chemistry education specialist at Vernier. I taught for 34 years chemistry and physics in Maryland. I've known David Vernier since 1984, so I was building sensors for Apple II computers back in the 80s, and have along with Vernier, have progressed through the different sensors and softwares and used them with my students in the classroom. Made lots of presentations and workshops, not just in Maryland, but all over the country. And having a lot of fun working at Vernier, not quite as much fun because of COVID, but still trying to make the best of it. And working with people like Melissa and Elaine at Vernier really makes my life so much more fun. So I'm looking forward to sharing some things with you guys this week and next. How do you teach electromagnetic spectrum virtually and engage your students? And that's what we're going to try to do with you today.
Yeah, and like I said, I'm Melissa Hill, and I'm one of the chemistry staff scientists here at Vernier. I've been here about 10 years, and before that, I taught at the college level. So like Noose said, we're all former teachers here that do the technical support and do the training of the teachers. So we, while we don't understand what you're going through right now with COVID and all this, we do want to help you as much as we possibly can and put ourselves in your shoes as much as we possibly can and give you all the tools you need to survive in this, this shift to virtual teaching and hybrid teaching. And with that being said, we have a couple of questions we want you all to answer. We'd really like to get to know the audience and who's here so we can kind of address your needs. There's a poll popping up there in front of your screen. So how is your institution handling the return to the laboratory specifically this fall? We know some people are doing 100% in-person labs with, proper safety precautions. Some people are doing a little bit of a hybrid, and some people are 100% online. So please answer that, one that applies the most. And then, of course, what courses do you teach? Are you teaching high school chem, AP, honors, college chem, or are you a biology teacher that's wanting to learn more about the electromagnetic spectrum and how to teach it? Just answer all of those. And while we're doing that, I'm going to reiterate some of the things Angie mentioned when the session started. If you have questions, please use that Q&A feature on the bottom of your screen. I'm sure you're all very much aware of the silence that can be in virtual meetings. So go ahead and make sure that Q&A feature works right now. Say hi to us, say hello, pop something in there. Noose and Angie will be answering questions as we go, and they're gonna just interrupt me if you guys have a question that needs to be addressed right away, or if we get to the end, we'll talk as a group. Something that Vernier really loves to do with its workshops is make sure that the participants leave with something, that they come away with resources and other kinds of stuff. So we want you to make sure you do not forget to go to this folder that Angie put in the chat panel. And it has a huge set of resources, and we're going to go through all of these today. It looks like a lot, I know. So we're going to do a ton of stuff today, and you're going to have all these resources to go back to. So you don't have to remember everything. You don't have to know exactly what I'm doing, because you're going to be able to go back and access all of it. But make sure you go to that folder and that link, and that's what you're going to go away with today. And it does include this presentation. This presentation has a lot of helpful links in it. So definitely look at it. You'll also get a recording of this workshop emailed to you a few days after the workshop. So you can look forward to that. But yeah, so who do we have in attendance here, Noose?
Looks like we have about 15 out of 17 people that are looking at the poll. It looks like, let's see, who do we have? About, of those people that have answered, it looks like 44% are high school. Those 3%, 31% are AB, IB teachers. We have about 19% college people, and then 44% other. I'm curious. Are those the biology folks that are lurking in the chemistry workshop? I'm looking forward to helping them if we can. As far as what's the breakdown, and I haven't stopped the poll yet because people are still voting. Looks like we got 6% of the folks are 100% in school labs, hybrid about 41%, and then 53%, so more than half, are doing labs online, which is quite a challenge. Looks like 94% have voted. So here, let me end the poll, and let's see what happens when I end the poll here. Can I share the results with everybody? Just out of curiosity here.
Yeah. Oh, there we go. Awesome.
There you go. So,
yeah, so if you said other, go ahead and throw it in the Q&A, what you're teaching, so we can help you out as much as possible. I suspect some physics people might be in here. It looks like there's some lab techs. So great.
Yeah, lab tech at Shasta College. That's cool. That's very cool. Yeah.
So before I get into the electromagnetic spectrum, the topic of the day, I want to make sure everyone who is attending today knows about all of our remote instruction resources. When the shift happened to online teaching, Vernier was working just as hard to get resources out to you guys as you probably were to get resources to your students. It's changing daily. I want to make sure all of you know about all of our resources. Go to vernier.com. And the first thing you see right here is this Explore Remote Solutions panel. You click on that. You scroll down, you self-select what you're teaching. Looks like a lot of you were high school and college, so I'll just go into the high school section here. But in this, there is an entire webinar dedicated to everything about remote learning, and it goes into a lot more detail than I'm going to go into right now, but definitely check that out. Talks about a lot of our different resources. Some of the resources in there that are mentioned are Pivot Interactives, which is a great online tool for distance learning. There's a free 30-day trial of that available. I'm going to briefly mention it at the end of this presentation in terms of how it can help you teach some electromagnetic spectrum stuff. But that's a really great resource for all ages and all disciplines. Vernier Video Analysis is a great app. It's really good for physics and doing a lot of like Newtonian stuff. But there's also a free trial of that. I'm not really going to talk about that too much. And then we also have some Arduino coding activities for those of you doing engineering. I know a lot of chemists do a lot of double duty in physics and engineering. So just making sure you're aware of those resources, go to this page. But what I'm going to focus a lot on today is this sample experiment data library we have. And this is for all disciplines, all grade levels. You click on this, there's a nice little page here that tells you how to use it. It can be a little overwhelming, and you'll see why, because I'm going to go into this library and there's just a ton of data in here. And everything in here was taken by one of the scientists at Vernier. So we have biologists, we have chemists, we have physicists. All of this was taken by one of us. And what you have here on the far left column is the actual data set. So we're going to talk a lot about Beer's Law today. So if I click on Beer's Law, it opens a Google folder, a shared Google folder that has the AMBL file in the case of this experiment, which is the graphical analysis file. And then it has a Word doc that has the student instructions for that particular experiment. To know which software it uses graphical analysis. That link in the middle column there takes you to the page to download the app. So if I was going to use this with my students, I would send them this link and say, make sure you have this piece of software and you've downloaded this folder. And then if there's a video, it would be over here. And this, your students can access this, you can access it, you can make some kind of hybrid if you like as well. You don't have to send them directly here. But there's a ton of data in here, and it shows you some of them have Logger Pro, some of them have instrumental analysis, and some of them have spectral analysis. So I believe the kind of the intro email that you were sent was pointing you to this page. So spend some time on it. It's a little bit overwhelming. Definitely spend some time there. Okay, and then around this time of year, especially with a lot of the remote learning, we get a lot of questions about software distribution. A lot of people are still using Logger Pro. It's a great tool. Make sure you're contacting us if you're not sure if you have a site license. There's no reason to be using that 30-day demo if you don't need to. And then definitely go to your Vernier account to distribute it to your students. Graphical Analysis 4 and Spectral Analysis are both free, so students can get that pretty easily. I'm also going to talk about Graphical Analysis Pro today. It's a brand new piece of software that we are offering, and it actually allows you, instead of what we just went through with that really complicated Google sheet that had a whole bunch of stuff, you can put the video and the data set and everything all in one file. So that's what we're going to talk about. And then again, I'll briefly talk about Pivot Interactives. So on to the name of the game, teaching the electromagnetic spectrum. Again, today we're going to be talking mostly about absorbance and transmission of light. And I'm going to be talking about two experiments. The first is Beer's Law, and it's kind of a more straightforward cookie cutter experiment that you would give to your intro students. And the second one is higher level inquiry style experiment that connects more of that transmission of light and absorbance. So starting off with Beer's Law, introductory chemistry. You've just spent a month talking to your students about this concept of the mole and molarity and solution chemistry. And now they finally get the chance to understand and grasp some of that with a really visual representation that is light transmission showing the difference in concentration. So that's what Beer's law is, and our experiment of chemistry with Vernier, experiment 11, goes over that really in detail, and that's what I'm going to talk about today with the colorimeter. And but you can also do it with our spectrometer. So what is the difference between a colorimeter and a spectrometer? Why would you want to use one over the other? The spectrometer tells you the absorbance or transmission at every single wavelength of light that spectrometer has available to it. In the case of our SpectraVis Plus, they go from 380 to 950 nanometers. So you get every single wavelength and you get an absorbance or a transmission reading from your sample with that spectrometer. That's a lot of data. It tells you a lot more about that solution than a colorimeter, for example. Ours only has 4 wavelengths of light. So you really get an idea of the difference in a full spectrum from the spectrometer to the colorimeter that only gives you information at a couple of data points. And going into the investigating food dyes and sports beverages, that kind of higher level AP Chem, maybe your freshman introductory chemistry course would use an experiment like that to really connect the idea of transmission of light and absorbance measurements. So you're no longer just trying to discover concentration or the color wheel, but you're actually trying to make that connection with students of where does Beer's law come from? You know, why can you use the transmission of light to determine concentration? So we're going to talk about both of those today. So let's go ahead and get started with Beer's law. And for both of these, I have in that folder, that magical folder that was shared out in the chat and that I showed earlier, they both have a video. And in this video, it goes through the entire experiment as it is written in our lab book. So not only do you get the student version of the experiment in that folder, but you also get this video that shows it as if the student was doing it. So here you are preparing the nickel sulfate solutions. In the case of this, how chemistry with Vernier 11 is written, it does use nickel sulfate. Realize there's a lot of really good reasons to not use nickel sulfate these days, but you could also do this with copper sulfate or food coloring. So it's showing the video and going through all the sample prep. It's also going to show students about that they need to pour that into the cuvettes and how you kind of have good experimental technique with all of that. It's also important to show them the colorimeter and calibration with water, which way to put it in the colorimeter, make sure the light path is going in there properly, and you're pressing the calibrate button. And so in the data collection of the case of Beer's law, it's what we call events with entry data. So that means I am putting a sample in my colorimeter or spectrometer. I'm hitting a keep button in the software and I'm telling it, this is the concentration of my sample because I've made a series of known standards. And then I want to determine the concentration of the unknown by comparing where the unknown absorbance value landed in this series of standards. So on the screen, it's the concentration, which is directly from the lab write-up. And then you see me typing in there that this is the concentration, and you can see the data set going in. And then at the end of this, I do have the unknown sample. And we kind of zoom in on the unknown sample so they see what the actual absorbance was. And then you give your students this. So this is the graphical analysis student version of the data set. So it just has the raw data. There's no analysis whatsoever. So you could have your students, you know, if they collected this, how are they going to determine the concentration of the unknown sample? presumably they're going to do a linear fit. So in the software directly, apply a curve fit, linear, and talk to them about graphing, talk to them about data fit, talk to them about analysis. If you're doing this with some AP students or higher level students, they definitely need to take that unknown value and plug and chug and get that concentration. But if you want them to confirm their hypothesis or their plugging and chugging, you can turn on the interpolate feature in graphical analysis and have them find that 0.29, drag it along, that 0.29 that the unknown sample read the absorbance of, and that's the concentration, and that should match what they get out of this linear fit. So in the experiment folder here, you'll see there's also an instructor version of this lab, and that just has all that data analysis saved for you already. So you can have both versions. Make sure you give your students the student one, and then you can use the instructor one for you. All right, so yeah, in this presentation, again, there are links to both those files. And so now I want to show you a little bit of the Graphical Analysis Pro and how this file can be improved if you have the video directly in the data set. So Graphical Analysis Pro looks exactly like graphical analysis. This is it right here, you're looking at it. Really the difference is you'll see that there's this sample experiment little icon here, and then when you get into it, it looks a little bit different. So we have here some sample experiments for you to download, and Beer's Law just happens to be one of them. If you scroll down, or you can filter to chemistry, you can see kind of a lot of our samples. And then you scroll over and make sure you've downloaded it or play the Beer's Law file. And now I have the video embedded directly in the graphical analysis file. So if I hit play here, the students see the data collection, a very similar video to what I just showed you, directly in the file. Now, because this is an events with entry type of data set, like we discussed, where I have to type in and say, this was the concentration, the data isn't yet able to sync with the data collection. But I'm going to show you some time-based data later that'll show you why that's so important. So then that's Graphical Analysis Pro. It does have a free 30-day trial, and it is a site license. So that means you can put it on all your computers in your school building or your college department, including students' personal computers. It's a great way to teach virtually.
And just remind everyone, it also runs on everything else.
That's right. It's Mac, Windows, iOS, Android, and Chromebooks. Okay, so on to our next experiment. The AP Chem Lab experiment number 1 is called Investigating Food Dyes and Sports Beverages. And this is a higher level lab, so you're kind of already expecting them to have seen some spectroscopy, to have seen some instrumentation. But now they really need to make that connection of what the transmission of light is doing for absorbance measurements. And, oops, hang on. There we go. Now I'm gonna pull up the video. So you can talk more about the color wheel, you can talk more about instrumentation, because all good scientists, chemists, adults should know a little bit about how science works and the real behind the scenes CSI stuff, if you will. So this particular lab is with blue food coloring number 1. So you can see here making the series of dilutions. This is a similar concept to the Beer's Law we just talked about, but it's all inquiry based. So the lab is written to ask the students how they would determine the amount of blue food dye in a sports beverage. And since they know a little bit about Beer's Law, they understand some of that, they can kind of make up that lab themselves and do the series of dilutions with blue food coloring number 1. Also in this video, I have a little bit of a transmission by eye kind of look at, and you could have the students stop here and be like, well, that blue food coloring, there must not be very much in it, and you could just look at it based on your eye. But we're gonna get a little bit more quantitative, and we're actually gonna observe and see the spectra of the sample. We do need the spectrometer to be in percent transmittance mode. And because this is an inquiry style experiment, students can design the experiment themselves, right? A lot of them may do what we just did in a Beer's Law, events with entry style, because that's what they're used to. But what I would have done when I was a student, and what a lot of my students did, is they would just take the full spectrum over and over and over again for all their samples and compare those. And I thought that's a really good way to show the full spectrum. It's a good way to understand why you're picking a particular wavelength. I also thought it was a good way to teach instrumentation and troubleshooting. So in the beginning here, you're just calibrating with your distilled water in the percent transmittance mode. I'm also showing this on a LabQuest 3. And a LabQuest 3 can data share to Graphical Analysis 4 if it's all on the same Wi-Fi network, which is a great way if you're in the laboratory right now to maintain that appropriate social distance, so all your students aren't all huddled around your LabQuest, to actually do some of this data sharing and stuff like that. So that's why I wanted to show it to you this way. But this is a great reason that troubleshooting instrumentation is helpful. So I always like to do a warm fuzzy when I start my spectroscopy data and actually measure my distilled water and make sure it's a flat line. Well,
that's not flat.
Exactly, right? That's what your students would say. So but a lot of software auto zooms. It's trying to be helpful. It's trying to zoom in on what you want to see. Students would immediately say, my spectrometer is broken, what's going on, and this is a great way to teach them, well, you should look at your scale, or you should zoom in and zoom out and do a lot of things that real scientists come in contact with, and we need to make sure our students see some of this and not child-proof it for them so much. So that's what I would always start with. And then now we go into our first most concentrated sample, measuring the percent transmission. And so their pre-lab was for them to determine the molarity of the solutions. So the molarity is not listed in the video because I didn't want to give the answer away if you're giving this directly to your students, but there's a nice full spectrum there of our most concentrated sample. And then the video goes through and does this for all 8 solutions. And it gets a little bit faster. Make sure you're storing the data, and then I get really speedy and go really fast. And so by the end, you're also again doing the unknown concentration. And at the end of all of this, you give your students the sample data set that is in that magical folder. Again, there's a student and an instructor version. And this is what the student one looks like. So a lot of my students would always ask, why, in the Beer's Law one, we just tell them use 635 or 565, whatever wavelength we're telling them to measure it at. But why? And on the AP Chem exam, that's what they're asking them. Why do you pick that wavelength? And this is a great illustration of, well, you don't necessarily have to, but it's giving you the biggest spread in all of your samples. It's giving you the biggest linear range that you can. I could pick this wavelength if I wanted. They're all different. Maybe you can have your students play around with some of that and really understand why you're picking a specific wavelength. But your students would ultimately, hopefully, come to this conclusion. And they can see all the solutions in here. They can see the sports drink, unknown. And the lab walks them through really nicely, making this data table where they got the raw percent transmittance that I just showed, but then they go into making calculated columns and things like this. So how a student might want to do that, they can do all of that in graphical analysis. I know a lot of people are really attached to Excel or other programs like that. You're more than welcome to do that. But I wanted to show off manual entry mode in graphical analysis and show you how you can have your students do this type of analysis directly in here. So you make your columns. Students will have calculated their concentration in the pre-lab. Students are getting their percent transmittance from the data file you gave them. And then they can start filling in here. So my concentration was 5 times 10 to the minus 7. My transmittance there was 20, 6 times 10 to the minus 7. And so now it's, 25 or what have you. When you fill all that in, and now you can make your calculated columns directly in graphical analysis. You just click add calculated column. First thing I want to do is remove that percent. So just transmittance. I want to use an expression where I multiply it by 0.01. So all of this is already built into that free software that you can use on computers, Mac, Windows, Chromebooks, iOS, and Android. And I'm not gonna make you watch me type, but that is what is in this instructor file that has all of the calculated columns in here, how the students would do it. And basically they go through and they look at all of the different ways that they have made those calculated columns and see which one gives them a linear response. So hopefully they come to the conclusion that minus the log of the transmittance gives them that linear response. And now they can use this to determine the concentration of blue food dye number 1 in sports drinks. If you were so inclined to use Graphical Analysis Pro here, wanted to take advantage of that 30-day free trial, you click on where you manipulate your graphs and your data tables up here, and you turn on video. And this is where you can import a video that you would give to your students. So the magical one that is in the folder there is this investigating food dyes. You can also take your own video. I know a lot of you guys have probably already done that. Can add that in here real easily. You save it out and then you send it to your students and that video will be embedded there. So again, let's go back here and make sure I covered all that. Yeah, all right. So with the GA Pro, I do want to mention, again, because this is events with entry data or spectral data, which isn't very exciting to link in time. One really good example that you could use to teach the electromagnetic spectrum, but you're probably going to use it more for kinetics in the spring, is that tried and true crystal violet lab, which there is an example of in here. So the rate law determination of crystal violet, if I load that in, and this file has been saved with the video, with the data set, but the data here, because it's time-based, is actually synced to the video. So this replay up here, if you're making your own, you would synchronize your video playback. And what this is saying is that when data set time 0, when the video gets to the 50-second, then the data will begin. That's what all this is saying. And you can set this up if you're doing your own video and your own data set, but we've already done it for you with this sample experiment. And so if I collect up here, the video is going to start and it's going to show my crystal violet data collection setup to give you context, where the experiment's coming from, give those students context if they're not able to do it themselves. And here I'm just mixing crystal violet and sodium hydroxide, pouring it into the cuvette, putting it into that black box, and now we no longer get to see the color of the crystal violet change. But for the purposes of this video, I set a test tube aside with the excess there, so you can see the decrease in absorbance over time, which is also filling in GA at the same time. So you can see how the purple is decreasing and the absorbance is decreasing, and they're synced in time. So you could use this to teach the electromagnetic spectrum, but it's also a resource for you there when you're doing kinetics later in the spring. And if I pause data, it will pause the video as well. So that's a little bit of Graphical Analysis Pro. And let's go back here. And okay, so that was what I wanted to talk about with the Vernier Labs and show you guys some of the resources we have for you there. Pivot Interactives is another online resource that you may want to investigate. It has a 30-day free trial. And it has a really interesting way of teaching Beer's Law. A lot of people really like it. It's a much more visual representation of Beer's Law, and students have to do a lot more by eye. So a lot of people have really liked that, but it's definitely worth looking into. And you should definitely take advantage of that 30-day free trial for Pivot Interactives. So I was recently at a ACS webinar, and educators were asked, what support did you utilize in this transition to remote instruction? And a lot of people relied on their coworkers, but a lot of people also relied on organizations like AACT, ACS, vendors like Vernier. But basically, I just want to congratulate all of you. You're doing great. You're looking for resources out there. This is a hard time for everyone, and whatever resources we can offer you, we want to know about. If there's anything else you guys need help with, or if you have any questions of anything we've provided, there's definitely our website. You can call us, you can email us, you can chat with us on our website. And we still have plenty of time here today to answer lots of questions. So, Noose, has there been any questions we should go over?
Not too many that I couldn't answer. Let me look back and see what I looked at here. The one question that came up was copper sulfate with doing Beer's Law, and the comment that I made was that copper sulfate works fine, same concentrations. You're just looking at you're looking at a shoulder instead of at the lambda max, because copper sulfate's lambda max is, gosh, it's almost in the infrared. So the 630 nanometer LED puts you on a shoulder, but that's something that does demonstrate the advantage of the Spectroviz, because there you can look at that spectrum and decide why would you choose that wavelength over one of the others. So that was one that came up.
And in fact, so that is how the Beer's Law in Chem A is written, is with copper sulfate. And it does give instructors a lot of confusion using the colorimeter versus the Spectroviz. As Noose just said, you're looking at the shoulder, how it's written. So the concentrations are going to be lower if you're using the Spectroviz. So just keep that in mind and pay attention to the instructor notes. We address that in there. But there are different concentrations depending on whether you're using a colorimeter or a spectrometer.
I just saw a couple pop up here. I had to step away from it. Oh, these are just they weren't really questions. Okay. The question came up, can we watch the video later? Yes, you can. You will get a how's it work, Melissa? They get a link in an email or something? Is that how it works?
Yeah, so they're going to get an email follow-up that's going to have a recording of this, and in that recording will be the link to the Google Drive. You've already been given the Google Drive link, so you could just hang on to that and share it with your coworkers. And I'm showing it here on the screen. This is everything that's in there. So you have access to it right now because it's been shared in the chat. So make sure you click on that link and can access it and all that kind of stuff.
Yeah, I had a question come up about the cost of the SpectraViz, and I responded to that. It's the U.S. cost is $399. One thing to be aware of: part 2 next week, we're going to be looking at emission spectra. To do that, there is an additional part, right, Melissa, that they need to get to do emission spectra?
Yes, the fiber optic cable, in order to do emissions of like gas discharge tubes or flame tests. I know Noosa is going to be showing a lot of really cool flame tests next week. You need to purchase the fiber optic cable separately. I think that's like $69.
Yeah, I think that's right.
And so if you wanted to do kind of looking at more of the elemental, the gas discharge tubes, the flame tests, all those types of experiments, you definitely want to also get that fiber.
Answering some questions here too, so
yeah.
I'm glad to see it. It's great. Someone has a question about old equipment here. Let me get to that.
Yeah, so let me so a lot of you guys are probably Vernier customers. I can address kind of generically repairs and older equipment. We do always try and support those as much as possible. Definitely shoot us an email or give us a call. The typical way we deal with old equipment that you think needs to be repaired is we try and troubleshoot with you over the phone or via email as much as possible. And then if we've determined that you do need to send it in for repair, so a common repair is like with LabQuest 2's, that power button will get stuck under the plastic or something like that. That's not something you can fix yourself or we would expect you to fix. So we send you an email that has a return authorization number, an RMA number as we call it, and then you mail the LabQuest into us, we repair it, and then we mail it back to you. And that whole process can take a couple of weeks. So definitely try and, you know, a lot of people will make it a yearly habit to kind of go through their equipment at certain times of the year. We know that's not always reasonable, but definitely that's kind of the process. And you can always email chemistry@vernier.com. You can email support@vernier.com, especially when it's something as general as a LabQuest. Yeah, let's see what else has been coming in.
One of the comments was that I'm seeing, or one of the questions I see is about Vernier support. And I was in the classroom for 34 years, and 30 of those years I used Vernier equipment. And you know, people would ask me, why don't you use some other company's equipment? And you know, I was like everybody else. Budgets were limited, and you know, I knew that I could deal with this company and that they would fix whatever I needed, whatever I had. You know, and you know, we still fix equipment that's as old as 20 years old sometimes. And so that's kind of, you know, been kind of a trademark for Vernier. And one of the things, you know, on top of that was these trainings. You know, Vernier was, I did some of the very earliest workshops for chemistry, and people left with stuff they can use. Look at this folder that Melissa's got up on the screen. All of that is for you. You're welcome to use that any way that works for you in your classroom. And we're trying to bring as much as we can that this feeling of a live workshop to you. And Melissa did this with what you see here. Next week, we're going to do it again. We're going to switch to emission spectra, but you're going to get a folder full of sample files and data files and things that you can hopefully immediately start using with your students. Melissa, can we mention anything else about Graphical Analysis Pro?
Yeah, let's see. Sure, we can. So how about let's show kind of how, if I made my own video, how I would import it with a data set from scratch as an instructor. So let's get a brand new, so I'm going to open, let's see, let's find a, what's a good example of some data sets? Oh, let's do molar gas. That's a good one. So in last week's webinar that Noose did, we talked about the advanced chemistry experiment determining the molar volume. And so that in this lab, you're putting a piece of magnesium in with some hydrochloric acid and watching the hydrogen gas change the pressure with a gas pressure sensor over time. You're also monitoring the temperature. You're using some gas laws to determine the mole ratio. So this is the raw data that I would collect with my gas pressure sensor and my temperature probe that the student would collect or I would collect, and say I videotaped myself doing it at the same time. So first thing I'm gonna do, I'm gonna just put one graph just to make it a little bit cleaner and show my pressure sensor data. And then I'm gonna open this video window. So literally the only difference right now between what you see in graphical analysis when you use it is that this video thing does not exist. So this video and replay and all this synchronization is really the only difference. So it's not like you're gonna have to rewrite all your labs or anything like that. The whole format didn't change. We've just added this capability. And then I'm gonna click on import video. And now I need to navigate back to find that. So the videos can be imported. I use MP4s. You can also use them as movies. So if you took the data on your iPhone, you would have, first off, most people have iPhones, and iPhones have this really weird high efficiency setting. You're going to need to change that. That's the first step before you take any data. But if you just videotape, you set up a lot of, you can get really inexpensive just holders that'll hold your phone on a tripod, and just set, as you're doing the experiment, videotape yourself. That may be a huge video. So on our website, we do have some recommendations for some different video compression software that are free. Handbrake I've used a lot, and it makes it a little bit smaller, so it's easier to distribute to your students. But you can use the full-size video. At some point, the software might balk a little. But just in terms of what you actually need to get a video into GA, it needs to be a common movie format, MP4 movie. We typically recommend less than 10 megabytes, but it can handle a little bit more than that, but that's what we recommend. So if I play this video, so this video is me setting up this, this experiment. And what I do in my labs, because it's a little, it can be annoying to try and find where exactly you started data collection. And in order to synchronize, I click on that little link and I have to click on this. And I want to synchronize my video playback. I want the data set time to start at 0. But now I need to find in my video where I actually pressed the collect button in order to get this data set. And so for me, I put in a little cheat sheet of a Vernier collect button. And then I know that at this time, this 37.69 seconds, if I wanted to be that accurate, but I'm gonna just round up to 38, that at 38 seconds, I want my data collection to begin. And so now that's my data collection. And so so now I'm going to put the video back to test to make sure everything worked. And I'm going to hit play.
That's why you put that little play button in there. How smart is that?
Yeah, that's what those all mean.
I've been watching those for a couple of weeks now. It's like, how smart. I never would have thought of that.
Yeah, and if for people who used Logger Pro video analysis feature, a lot of those were physics videos, and they were just the data collection. So you could do this, but you didn't usually deal with it. It wasn't kind of how it was designed. But now, because we're trying to do more chemistry and more, so you can see here, the data collection started when that at 38 seconds. But now that we're doing more chemistry and biology videos, we really wanted a way to have users be able to see the context of the video and be able to synchronize the data and see the experiment as it goes. So
what's that box that's between the two panels? What happens if you drag that?
This resizes things.
Ooh.
Yeah, so you can make that a little bigger. I can close this because that's taking up a lot of screen.
Yeah.
But yeah, so you can see the video better, and so students can zoom in and say, oh, look, it's bubbling, there must be some gas, and oh, look, the pressure is going up. But yeah, that's how you add a video yourself. But like I mentioned previously, we do have a lot of sample experiments preloaded in there for all the different disciplines: chemistry, bio, middle school, and physics. And you can make it, okay, now the video gets really boring, so you can make it really small.
Chemistry videos are not boring.
Never.
Yeah.
But that's GA Pro, and so some things that will be added in GA Pro, because right now we're offering an introductory as at the $69 for the site license. That's because it's not full featured yet. Really, this synchronization is what you get right now. But we, like all our software, we're constantly adding more stuff. So a lot of things that'll get added to this is going to be synchronization with the events with entry data, which chemistry is really excited about. A lot of our data is very, I had to tell you, I set this concentration up, or I input this much volume, like a titration, for example, or a Boyle's law, for example. So that will be able to synchronize like this, which I think will be really cool. You can go to a moment in a titration and actually see what the color of the solution is as I tap along. Or with Crystal Violet, I can tap along. So this one's not very interesting, but I can click anywhere in here and it'll go to that point in the video. So that's pretty cool too. But that'll be added. And then too, a lot of people miss from Logger Pro the ability to type in your own calculated column and data collection fits. So that will be in GA Pro. But I can also speed this up because super boring data. You might want to look at it at 10x. I think I have to pause before I do that though. And then it'll go a little bit faster. Yeah, and then there are multiple data sets in here for the different magnesium strips. And so you'd see that. So eventually you'll be able to have a different video for each one of these. But that's GA Pro in a nutshell. Oh, a question came in about nickel sulfate not being safe to use. Not that it's not safe to use. I said there's a lot of reasons you might not want to use it, predominantly because you have to get rid of metal waste. Nickel cannot be put down the drain. So it costs a little bit more money to get all that and dispose of it safely. So that's one reason you might not want to use it. I believe you definitely look up the SDS sheet on it before you use it. There are some other implications of using nickel sulfate, but that's the biggest reason most people are getting away from it.
There's a question that came up about developing an electronic notebook. We don't have anything in the works particularly for that right now that I'm aware of. One thing about graphical analysis is it does allow students to export the graphs on the screen in an electronic format that then can be imported into an electronic tool that you might be using. I used a Google Slides template for my younger students, and what you can do is you can export this as a PNG, as Melissa is showing, and then import that into something. But there's nothing particularly from Vernier that I'm aware of. Melissa, do we have anything that looks like an electronic notebook?
No, we do have a relationship similar to how we have a relationship with Pivot Interactives. We have one with Lab Archives. So a lot of colleges use Lab Archives as their electronic lab notebook. A lot of our labs are preloaded into there. A lot of our data sets are preloaded into there. But most of that work is on the Lab Archives side, and I don't see Vernier doing any of that anytime soon, but definitely check out the Lab Archives information on our website, because it's a pretty cool way to have a lab notebook and to integrate Logger Pro or graphical analysis into it.
Yeah, there was a question about, can you show videos in GA? And my response was, unfortunately, no. The idea with GA Pro was to have this ability to combine videos with data. What I demonstrated last week was to put the video side by side, but it's not synchronized when you do that. Yeah. So we have just a couple minutes left. Melissa, do you want to talk about the future of our presentations and also maybe training if anyone needs it?
Oh, absolutely. Let's go to the Vernier website, and if you go to educator training, just click on that tab. First of all, if you just mouse over it, that's where a lot of people have been asking about videos. There's videos here that you can search through, safety data sheets for our stuff, all of our product manuals. If you need help with your pH probe, you can look up the manual right there. But if you actually click on it, it brings you to this page. This is our main training page. And I know we still have some updating to do, but you have here a way to browse all of our fall virtual workshops. And we have them for physics, biology, and chemistry. So right now we're here on September 30th. So there's a physics one tomorrow. Next week on Tuesday, Noose is going to be talking about emissions with the spectrometer and flame tests and lots of cool stuff. So definitely sign up for that one. You can register it directly from this page. And there will be physics. Every week we're trying to do one from each discipline, physics, chemistry, and biology, and we kind of rotate through them. So physics next week is Newton's law, and then cellular respiration for bio. And then later on in October, we have a couple others. Photosynthesis, we'll be back here talking about acids and bases and how you can do titrations virtually with your students. And then a physics one there at the end of October. So those are the fall workshops. And not only that, but we also do personalized online training. And if you want some one-on-one training with us, you can request a workshop directly here and then look at our video library. So that's a nice, helpful landing page there.
Question was, when was the one for October 6th? I don't have that screen right up on my screen. You have access faster. Oh, that's me. Okay, that's me.
Oh, it's at 1 p.m. Pacific.
Yeah. We're 3 hours behind you guys on the East Coast, so sorry about that.
So I am recommending, there's been a lot of question about, I know these are in the middle of the day. I still recommend people sign up for them and register for them, because then you'll get that email that has the recording of it. So you'll be able to see it. So if you are interested in that topic at all, register for it. If you are unable to make it last minute, you'll still get that recording in a follow-up email. All right, let me stop sharing. It looks like we've gotten kind of to the end of our time here. And feel free to stick around and ask more questions. Looks like some more questions are coming in. But again, you can always email chemistry@vernier.com. You'll get me, Noose, or Lane. There's only 3 of us, so now you can put a face to the name. We're always here to help. So please come back for more webinars, and stay safe out there. And yeah, we'll see you next time.